haloalkanes. Let's just see how to name these haloalkanes. Okay, so there's sometimes different kinds of substituents that are not carbons. For example, if you have this carbon derivative, it's possible to have other substituents, and a very common one is the halogen substituent. When you have a halogen branching off of a main chain. So it's kind of, now in this molecule things are kind of crowded, but it's quite a little bit complicated of a molecule, but let's just look at what we have. So we need to first know how to name these groups. In alphabetical order, if it's a bromine atom, we name it bromo for a bromine atom. If we have a chlorine atom, then it's chloro. If we have a fluorine atom, we call it fluoro. And if we have an iodine, we call it iodo. Now, of course, now we need to identify the groups. We have 2 chloro groups, 1 bromo group, 1 iodo group, an ethyl group, and a methyl group. Really crowded. Now we got to identify the longest carbon chain, so that's fairly simple. However, do not circle like this. This is not a 1, 2, 3, 4, 5, 6, 7. This is not. See, sometimes you might accidentally number as the molecule, the carbons in the molecule, as well as the substituents. But you don't number the substituents, remember. This isn't a 1, 2, 3, 4, 5, 6, 7, 8. This isn't an octane derivative because it's actually a 1, 2, 3, 4, 5, 6. It's actually a hexane derivative. And the reason for that is because this is a bond to an iodine atom. So it can't count as a carbon, so we chop that off. And then we stop here because this is a bond to a chlorine atom, so it doesn't count either. Okay, now we gotta look carefully. A, B, C, D, E. So the ethyl will be named before the iodo. However, the iodo will be named before the methyl. By the way, I'm not writing out the names of the groups. Now we've got to number these in such a way. Now again, there's still 2 on the same carbon, so we've got to take for alphabeticity, so we'll number it right to left because the chloro occurs sooner. So now we've numbered our carbons. Wait a minute, I think I numbered it wrong. 3. Yeah, sorry, I numbered it wrong. 1, 2, 3, 4, 5, 6. I skipped the 3. Man, I really eat numbers, but sorry about that. So now we gotta name them. We gotta name the bromo group first. So we have 2 bromo. Now we need to name the chloro, but we have 2 of them. So 1, 3 dichloro. And although in this case it doesn't matter if the prefix is still given into account, remember that in other cases it might have to put things forward. You might have to switch things over if the prefix was taken into account. So, because it is not taken into account for alphabeticity. Just remember that. So what we do with so now after the dichloro, we list the ethyl group. We have 4 ethyl, 5 iodo, 6 iodo, sorry about that, 5 methyl, hexane. Now, might be annoying about such a large name, but remember, we need to unambiguously describe everything about the molecule, which groups there are, where they occur on the molecule, and how many of each one there are. And the only possible name that IUPAC rules agree with that can do this is 2-bromo-1,3-dichloro-4-ethyl-6-iodo-5-methylhexane. It's a long name, yes, but this is the official name of that molecule, and we won't change that unless we develop even better rules. But so far, IUPAC's rules say that this is the name we are going to use when describing this molecule, so that anywhere around the world that you are, you can understand and agree on what we're talking about.